Right now, you are watching an artificial intelligence learn how to drive. It starts out knowing nothing about the world it inhabits and uses these 7 green lines that act as rudimentary eyes to figure out what's going on. In the beginning, it endlessly crashes into walls until eventually it gets lucky and drives decently far. The attempts that proceed will imitate this success until ultimately the AI gets so good it fails to flounder and never dies. This system is based off of evolution, where the best of each generation pass on their genes. This is accomplished through a fitness score, where each car is judged based on how far it drove, or, if it reached the end, how fast it finished. This system is quite common in machine learning, a subset of the artificial intelligence field, and is heavily inspired by the evolutionary term survival of the fittest, where the organisms that are the most fit to their environment reproduce and pass on their genes. The particular system I'm using right now, NEAT, separates each car into species, where species that fail to do well for an appropriate period of time will die out. This is shown on the table to the left as stag or stagnation, but more on NEAT and the specifics of the AI's brain later. The track is randomly generated for each generation. The hope is the cars will learn to drive on a multitude of situations. If I had just created one constant track for the AI, the track would essentially get etched into its brain. It would perform well on that specific track, but if you were to throw it onto a new track, it would perform the specific movements it had previously learned and crash into a wall. In the world of machine learning, this is referred to as bias, and it represents the need to place the AI in various contexts so it can do well in unfamiliar environments. The neural network is composed of a web of neurons and connections. The neurons are separated into 3 groups: input, hidden, and output. The input layer consists of the distances represented by the 7 green lines, which are like the AI's sensory input, as well as one neuron representing the speed of the car. The data in the input neurons is then sent to the hidden layer through the connections. Each neuron in the hidden layer has a special way of transforming the data in the input neurons and then combining them to create a new value which the neuron will store. The output layer consists of 3 neurons which correlate with turning left, turning right, and accelerating or decelerating. The data in the hidden layer is then sent to the output neurons through a similar process, and then the program looks at each value in the output neurons, and if it's high enough, the car will perform the specific action related to the output neuron. Alright, I'll let this play out till generation 100. That's about all I had to say. See ya.